is we already talked about questions on this yesterday, guys, but we're going to go ahead and just officially grade section 5.1, the bookwork. That should be done today. As you guys start grading, I'm going to come around and do a spot check on that section 5.1 because it was technically due yesterday. I gave a day of grace. Switch. Today is March 1st. As you guys are 5.2 today, I doubt we'll be able to finish it, but we are going to go ahead and start it. Talk about, once again, that worksheet, which is the 5.1 worksheet, technically slope field worksheet, in just a second. We'll do in section. Starting on section 5. Oh, who took my red marker from back here? Ooh, when you let kids touch your things. I'm not a fan. P.S. If you guys have not yet followed HCS_admissions 2018, you should follow it. I will even give you class time to pull out your phones and go on your Insta and follow it. You guys should follow HCS_admissions 2018, like the Havana Nights book, and help us spread the word.
Yes, I'll just go on my phone.
Well, I didn't say it was a call, but do believe Monday. Okay. All right, let me go ahead and scroll down for the homework. Do you guys already see 48? I think you did, right? Let me leave 38 and 48 up for a second because you guys are going on your Instas and changing stuff. You should follow me. I'm not very exciting on Insta. I won't lie. I don't remember that. MG, that sounds like Maggie, but isn't that Maggie? I don't know who Colleen is. Mrs. Hodgson made it. All right, let's go and get those phones away. That should have been enough time. All right, guys, 38 and 48 is up there. I think we already checked 38 yesterday. Wasn't that one of your questions? 48, though, is just filling out a table. I think you were just plugging into a differential equation. Is that right? Oh, okay, that's not too bad. Now we have number 90. Is that what's next? Okay. You guys didn't ask on number 9. Oh, no, we have 51 through 54. I apologize. I know you should have been able to check the odds, and then that should have helped you with the process of elimination for the evens, but still. There we go. You got it? Those are just matching. Now number 90. Now, wait. Number 90. Whoa, what's going on? They're just trying to explain. The final answer, look at the bottom, is D, right? No big deal. The final answer, look at the bottom, is D. Just trying to explain. But if you didn't understand, we actually went over this one, I think, in period 6, but not with you guys yesterday. The clues that Justin pulled out that he thought was most helpful, because I didn't see the picture, the book thing wasn't working. Anyway, it was a struggle. The clues that he pulled out that were most helpful, I thought, is that the slopes were following vertical lines, which meant only determining, yeah, the differential equation only had x, was only dependent on x. Had x, followed vertical lines. And then he also saw, I think, that there were horizontal slopes around x equals 1. And then undefined slopes at x equals 0. So then we had to figure out, and I was actually just kind of building it, had to figure out somehow that a differential equation could be only dependent on x. And I thought at first x minus 1 all over x, because I'm like, oh, hey, because he was just telling me the clues. And I was trying to build it because I couldn't see the options either. I was like, okay, that will give us a 0 at 1, and this will give us undefined at 0. But then I looked through the answer choices. This wasn't one of them. And I realized there was another one that was dependent on x and would give us 0 whenever x was 1. And what did the final answer end up being? Isn't ln of 1 also 0? Dun, dun, dun. That was the final answer, I think. Wasn't that D? Yes, okay, go team. And then number 92, the one that we talked about yesterday, but you guys can get further clarification, like on letter A, you have to follow the flow. It was something sinusoidal-ish. That's what I was guessing. I think I was trying to be nice yesterday, and we're like, oh, maybe not. But if you look at it, there just needed to be a sharp turn. There was a way to follow the flow. Now, if it was up here, it would be a little different. It wouldn't come down. So this should have never gone beyond that line. But there was a way to follow. There were some sharp turns. There were just some sharp turns. And then letter B, we already solved yesterday, right? You didn't have to do the decimal, right? Stick it to the man. Then be done. Technically, sticking it to the man, didn't I stick it to the man just by adding the 1 yesterday? And plugging in the 3.2? That was good enough. That was good enough. You didn't have to simplify it at all. All right, cool kids. That's the end of homework. Did you have any questions? We went over the evens yesterday that you guys had questions on. Were there any odds you got stuck on last night? Okay, cool. Let's transition to the worksheet. Ooh. Right now, where am I at? Class folder, handouts, assignments. True? Sadly, it wasn't up there yesterday, and some poor kid left their worksheet at school, and I didn't realize it till too late. But, oh well, now it's up there. I told them they could have an extra day. It wasn't your class, it was the other class. But anyway, Chapter 5, Slope Field Worksheet. Do we have any places where we got stuck on the process? Sean? Okay, 22, 23. Anybody get stuck earlier than that? Nathan? 17. Anybody stuck earlier than 17? 6. Okay. Number 6 was a sketching one. This one, right, Sarah? Okay. Number 6 was a sketching one. You guys, help your classmate out. Who has advice for Sarah on number 6? What's going on all the axes, guys? When y equals 0, what's going on? They're all flat, right? Because they're all 0. Except for 0 over 0. Do we have a way of sketching that? It would just be undefined. It's actually indeterminate. We'd actually just leave that one blank. But all the rest of them we can make flat. What are we going to do with all the ones where x equals 0 and y is a number? Straight up and down. What did you guys see in the first quadrant? All the slopes should have been sloped negative. A positive over a positive times a negative. They all should have been sloped down. Some of them less steep, some of them more steep. Second quadrant, that's where Sarah is. They should all be positive because the x's are negative and the y's are positive. So a positive over a negative is a negative times a negative is a positive. So, no, good. It does cancel out. So that means it's going to be a positive slope. Good. No, that's a good thing that you were right. That's a good thing you were right. Here, let me help you out real quick because, guys, if you notice real quick, what else joined the handouts assignments folder? Ooh. Sarah, does yours look something like this? Why? It was good. It was good. It's okay. Get it back. Get it back. But do you see the note right here? Why is nothing graphed at the origin? You can't be flat and up and down at the same time. A 0 over 0 is indeterminate, so we leave it blank. We leave it blank. Okay, coming back. Then we had, my next one that I heard was 17. Oh, wrong one. Oh, my goodness. Hi, hi, hi. 17? Anything before that? Okay. 17, which part? C, is that what you said? Oh, you guys. Pause. Isn't this function notation? Oh, the little pre-cal kids that oriented my board did not do a good job. Okay, how about this? Nope, that's even worse. How about this? Okay. This guy, isn't that function notation? Forget it. Isn't that function notation? So y of negative 3.1 is the same thing as f of negative 3.1, which means I'm trying to approximate f of x when x equals negative 3.1. Does that all make sense? Cool. So I'm trying to find a y value that will approximate the y value. So I'm trying to find a y value that will approximate the y value at negative 3.1. So when you make your tangent line, that was the easy part, right? Hopefully. Y minus y1 equals x minus x1. Nathan, where am I getting the slope? Nope. Your forever card says y minus f of a, so that's a y value at a, equals f prime of a, the derivative at a, x minus a. There's the a, there's the f of a, I need the f prime of a. Derivative, yeah, so what's negative 3 plus 0? Now, think about what I just said. The whole point is to estimate with a y value the y value at an x value. I want him when x is, got it. So all I have to say is f of negative 3.1 is going to be approximately the y, which is going to be negative 3 times negative 3.1 plus 3, technically plus 0. Stick it to the man and say dun 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 dun. Don't you dare try to simplify that. It's a long answer. Tyler. Okay. So I got the y alone, plugged in the negative 3.1, and that y approximates the y. Okay, that was number 17. I heard my next question, something about the 90s. Does anybody have a question before the 90s? Or 20s, or whatever they were? 19. Okay. 18C. Ooh, look, it's a burr. Okay, so it appears from the slope field that G has a local max at the point 0, 0. Does that make sense, guys? If you were to follow the flow, does it seem like it's coming up and then leveling off and then going down? Okay. Using the differential equation, prove analytically, aka without just saying, look, it looks like it, prove that it's true. We could plug 0 into the differential equation, and that will tell us whether or not we have a critical number, right? Can you test around it? But question, we know that there's a point at 0, 0, but do we know technically a point that's on the curve before 0, 0 to even plug in? That wouldn't be proving analytically, though. No, this is when we think there's another way to prove relative maxes and mins. You don't just need the first derivative. You can plug to the second derivative. First derivative needs points before, but how many points do we technically know on this curve? Because this is different than that one. We only know 1 point. Well, we can't. After we can look at it and say it looks like it, like kind of we did yesterday. Oh, it looks like it before. Okay, good. But technically, was that proving analytically? No. To prove it, we would have to say, well, we need to be able to use just 1 point, and the only relative extrema test that uses just 1 point is the second derivative test. The first derivative test says you need before and after. The second derivative test says plug in and check the concavity. So if we plug in 0, 0 to the differential equation, do you guys get 0? So I can do since, and the second derivative, at 0, 0 is, all right, wait, I can't fill that in until I find the second derivative, right? What is the second derivative? P.S. What's my first derivative? I can't see it anymore, and if I scroll, then I'm going to mess it all up. I heard a lot of different answers. Thank you. So wouldn't my derivative be 2 dy dx minus 4? So can't I do 2 times, don't we already know dy dx is 0 at the point? Does that make sense? 2, and then we already plugged into dy dx, which is 0. So 2 times 0 minus 4 is negative 4. So we can show that, which is less than 0. And Sean, even though we didn't have to write it because the graders, myself, or the AP graders would totally know the math that you are referring to, what technically is the idea behind, since the second derivative is negative, there must be a relative max? The function is concave, so therefore the critical number must be a. Now, do you have to explain that? No. You just use the second derivative test and said the 2 conditions that have to be true. You're done. Dun, 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 dun. Nope. We can't just say, hey, look, it changes. That's not proving. Because aren't there infinitely many different points in between there and there? So what if it does a little like, and then, yeah, see? Okay, I heard something about number 19. That was similar to the mx plus b one that we did yesterday. Let me leave you to the key for tonight on that one, if that's okay. Number 19, and then we'll see tomorrow if there's any remaining questions. P.S. What do you guys see on the backboard underneath the dotted line? 5.1 worksheet graded. The answer key is online, so grade it tonight and figure out what went wrong, yeah? And then see if you can push through what went wrong, figuring it out for yourself. Mrs. Leon would be a huge fan, not just getting the answer and then saying, oh, well, or waiting for the teacher to explain it to you, but actually learning. Okay, so see what you can do tonight on your own and come back with anything that's extra tomorrow. But I'm just trying to do a couple hints on the tricky ones. So I know some of you didn't even get to finish the worksheet yet. If you guys didn't notice on this, don't you see flat lines at 0 and at 1? Okay. But what's really sad when you go plugging in over here? Flat lines at 0 and 1s, flat lines at 0 and 1s, DNEs at... if I plug in 0, e to the 0 is 1. Oh, that'd be 0. And then plug in, oh, that'd be 0. And then, So guess what? A, B, and D are your 3 options. They're the only ones that will give you zeros at 0 and 1. A, B, or D. So how do you know who's who? Do you think that this sign difference might make a difference if you try plugging in a point like 0, 1/2, or 0, 3/2, or 0, -1/2? And maybe those sign differences will help you narrow down one and maybe keep one than you have between these two. What's E approximately? 2.71828. If you want to think 3-ish, that wouldn't be totally off, but 2.71828. Or if you want to think 3-ish, that wouldn't be totally off. Couldn't you also plug in y's there when y is -1/2, or y is 1/2, or y is 3/2, or if y is 2, or if y is -2, and see what's going on? You can check the answer key. What else do we have? I mean, 20, you're just going through and checking each and every one, right? What's it take to have a vertical asymptote? What will the slopes be? The line will be vertical, the slope will be dne, which means somehow I need to plug in 42 and get dne. That doesn't make sense. There's no x to even plug in anyway. Horizontal asymptote. Oh, the slopes need to be? Oh, I'm just giving too much away. Okay, what else do we have questions on? 20 what? 22, 23? These ones are nasty. How come? These are nasty for a very different reason. 22 is a little bit nastier. 23 is a lot nastier. They tell you the size, but what don't they show you? Oh, no, tick marks. Little meanie heads. But what do we know? Negative 2-ish to 2-ish, so can't we kind of put a tick mark halfway in between to be negative 1? And then negative 3-ish to 3-ish, we can kind of make little tick marks to kind of imagine what it would be, and you guys can mark up your graph if you want. But, do you guys see any zeros anywhere? If you follow the flow, there's going to need to be a 0 somewhere in here. Oh, there's zeros. There's a couple of them, not many, but there's one. There's one. So there's not a lot of zeros, but there are a few. It's not going to be as easy as some of the other ones that we've done as far as the zeros. So maybe if the zeros aren't super easy, could we play with signs a little bit? For instance, in the third quadrant, what are the signs of x's and y's? Both negative. And what are these slopes? So which of these, if you plugged in two negative numbers, will get you a negative? No. Not always. Okay, that one would be a negative. Not always. If you guys had a y that was greater than the x or any sort of y value, these ones are all negative, right? Do you see any of them? Anyway, my idea to you would be start canceling them out. Like this one for sure doesn't work because his signs don't work in that quadrant. You could also try something like, okay, well this one, the x's are positive and the y's are negative. I need the slopes to be negative. Well, if the y's are negative and the x's are positive, what other one wouldn't work? Actually, that doesn't really narrow anything down, does it? Is this an equals? Oh, nice. Then C and D are both gone. Okay, it's a little bit better. So kiddos, quadrants can get you somewhat far, but then at some point you might have to try testing points. Like for instance, couldn't we test the point positive 1 needs to plug in negative 3 when x is negative 3 and y is positive 1. We needed to have a negative slope. I did that because this one clearly goes to negative 1, negative 2. Now it starts to get iffy. Some are negative, some are positive. That might get iffy. But anyway, I saw quadrants where they were all negative, and I'm like, ooh, that's a thing. Now I see two quadrants where there's a lot of funny stuff going on. So I'm going to pick specific points and say, all right, well, hopefully you help me narrow some guys down. So anyway, we've gotten down to A and B and E on that one. Keep thinking about it, and then answer key. And then number 23 is super similar, except the only dilemma is, what do we have no clue about? We don't know the size. This could be a negative 100 by 100. This could be a negative 10 by a 10. This could be a negative 1 by a 1. I don't know. What do you think we're doing? Thinking about the signs. Thinking about the signs. And you could guess maybe like a 1-ish and a 2-ish and a 3-ish. You could guess that and see if that gets you to an answer. For instance, what do I see? I see here in the fourth quadrant, all the slopes, I'm checking, all the slopes are positive. Fourth quadrant, when x is positive and y is negative, I need everything to be positive, right? If y is negative and x is positive, is that sometimes going to be a negative? If I have positive 1 and negative 10, that better be a negative. Okay, that one's work. Because if y is big and x is little, well, no, the negative's going to win, so that doesn't work. Same thing here. If y is negative and x is positive, well, that's going to be negative also. I see negative y's with positive x's being positive. Well, that's not going to work. And to be honest, I think we could do the same thing here. Negative y with a positive x, that's going to be negative also. So far, we've just narrowed down these three by only looking at the fourth quadrant. Okay, I've narrowed it down to 2. You guys answer, keep going. So, what are you doing for tomorrow? pulling up the answer key with a colored pen, grading what you have done, and wait, what if you have stuff that isn't done? Oh, just looking at the answer key and filling it in. No. Learned nothing. Actually, probably went a few steps backwards. So therefore, pull up the answer key once you have it attempted and then go ahead and grade. Now, if you mark something wrong, could you just mark the right answer? I suppose, but what am I hoping you do? Power through and figure out why the answer is what it is. And if you can't figure it out, what are you coming with tomorrow? Any questions? All right, cool kids. So we went over Chapter 5, Section 1. We went over the worksheet, at least a few of your questions. Here we go into Section 5. What? This seems a little weird. 9.3? What's going on? I'm going to pull up your worksheet, sorry, your homework sheet really quickly. I have the Google Drive already open. Yeah, it is. Well, this whole chapter is pretty FRQ central, won't lie. Okay. It's our section 5.2. In other books, I had to go crazy at the end and look for the correct section. Our nice thing is it's really just 5.2. So things get a lot easier. I got a book that, well, basically I would steal this section out of a book similar to the one that we have from the same guy, the same publisher. So anyway, don't worry. It's our 5.2. It used to be really weird. I had to print out handouts. So sometimes you're going to see in the notes how I have the word handout in there. But the nice thing is for us, it's really just our 5.2. It's the next place. For AP classes, this is exactly where we always go, and so that's why it's nice sometimes to have a book that's an AP book, because it's like, oh, we don't need to wait to cover this. Let's just cover it now. Whoops, never turned off my sound. Lo siento. Okay. Nathan Bennett has requested to follow me. Go team. Okay. I want you guys, I have the bottom part of the notes blacked out on purpose. Well, whatever. Covered on purpose. Because I want you to actually solve that differential equation. Solve for the general solution. You guys know that wording from 5.1. Solve for the general solution. Hopefully my hair's not hitting the microphone. That'd be really annoying. Sorry. Integrate. You got to go backwards. Wait, but we can't integrate as is, right? Doesn't make sense. Good. Sean, first of all, said, hey, let's change this y prime. Oh, dear. To a dy over dx. Okay. Change the notation. Dy over dx. That's one good step. We got to get it bookended, though. How do we bookend it? Good. Multiply dx to the other side. But as soon as we multiply dx to the other side, hold on, what doesn't make sense anymore? The y can't stay, yeah. So move the y over here. Y dy equals 2x dx. Remember I said harder differential equations, or maybe not harder, but more complicated differential equations were coming, where the c's might not always be added on the outside, where the y's might, or I should say, yeah, where the y might not always be by itself. But we can still do it. We just need to get everything bookended. We need the dx to be multiplied up. We need anything with y's to be over here on the y side. And then when everything's nice and ready to go, what can I do? Yeah, throw in an integral, both sides. Yeah. You just haven't seen harder ones like this until right now. Well, I think we saw one or two kind of yesterday, but we didn't really do them all. This is totally legal because, look, I have a function of y in a bookend with dy and a function of x in a bookend with dx. It's totally legal, but any other way you would have done it would have been illegal. I couldn't have the dx still divided. I couldn't have the y stuck inside this x bookend. But now that I have it all separated, it's good to go. So kiddos, just think about it. If you had these as two separate problems, how would you integrate y dy? 1/2 y squared plus some sort of c, right? We'll say it's c1, because what do I need to do on the other side? I'm going to have, are you guys okay if I say 2x squared over 2, which is just x squared? Can I make that jump? Okay, good. We've gotten good enough at integrals to see it. Now hold on, what do you see on either side of the equation that's the same? So if that was a plus 1 and that was a plus 2, couldn't we just subtract and get a new constant? So we're not going to actually be writing this over and over it because we're going to save time and say, you know what, whenever we have to integrate two sides of the equation, we're just going to have a big old arbitrary constant on the side because we want everything on that side anyway. We need y by itself. So we're going to move, in a sense, the constant from the left integral over to the right. Does that kind of make sense? Just combining like terms. Let's talk about it right now. Tyler's, as he's saying, a square root because what am I supposed to be getting alone? And the AP is really good at this. They don't just say solve the differential equation, or else you could say, haha, stick it to the man, I'm done. No. They say solve for y equals, and almost always they say f of x or f of t or whatever it is that they want you to call it. They want y by itself. How we get y by itself? Well, multiply both sides by 2, right? And I get 2x squared plus, now, can't I say 2 times c is a new arbitrary constant c? 2 times any number will just be another number. I could make this c3. And if I'm 2, let's say it's supposed to be like a 7. Well, 2 times 7 would be a new c, 14. But y is still not by itself. So now we're up to what Tyler was saying about, like, doesn't it work the same way with a square root? Well, hold on. We need to square root. That's true. We don't know whether it's positive or negative. Remember how in slope fields, remember with the wind, depending on what country that you chose, what initial point was given, you might have different flow to follow, right? Okay, same thing here. I have to put plus or minus because I'm like, I don't know, you didn't give me a point, so I'm not sure exactly what flow I'm looking at, the positive square root flow or the negative square root flow. It depends on what point you give. So I'm going to have to do a plus or minus square root. And if you guys are like, that plus minus thing is always complicated because I'm never exactly sure why it's a plus minus, can I remind you why it's a plus minus? Technically in math, actually gets you to an absolute value, where it is always an absolute value. And absolute value equations are always solved by taking the inside, taking away the absolute value and saying, hey, it could be the positive or it could be the negative. Tyler's question is, well, why can't we just like put the plus c on the outside? And then be able to break stuff down. The struggle is, Tyler, you just killed a puppy. Those algebra mistakes show up even in weird calculus problems because can we distribute a square root like we would multiplication? No. Well, wait, can't we just factor? If we were to solve for the zeros of this, they would be imaginary. Remember, you can never factor as x squared plus 4. That would be x plus 2i, x minus 2i. That doesn't work. You can also always factor an x squared minus 4, which would be an x plus 2, x minus 2. But even then, does that have a nice square root? No, because they're two different factors. The only thing that we can square root is x plus 2 squared, because that would cancel with a square root. But that would be x squared plus 4x plus 4. Never factor in a way that we can square root a binomial with a squared and a constant. Long story short, you're killing the puppy. You're distributing that square root when it's illegal. So good question, but no. And we have to leave it like that. They didn't give us a clue. They didn't tell us where to start the flow. So we're like, I don't know. Could be the positive root or it could be the negative root. Just depends. Just depends. Do you guys see how the differential equations have gotten a little bit harder? But do our rules as far as when to integrate, when not to integrate still apply? Yeah. We need the integral to be able to be put with a bookend and a function in terms of the same variable on the inside. We need an integral to be with a bookend with a function in terms of the same variable on the inside. Then we just think of, oh, let's integrate both sides. It's kind of like implicit differentiation in that we just take it however it comes and go for it with the x's and y's all mixed up. The problem is with integration, we can't leave it mixed up. We have to at least get it organized and then take the integrals of both sides, like with implicit, how we would take the derivative of everything. But we just have to organize it first. That brings us to the bottom page of notes. Let me get rid of this little cover. And here's an application. Let's see if I can full screen it and let you guys see more. Yeah, that's good. Now that you've seen a more complicated differential equation, how the y can kind of get all messed up and we have to get the y by itself, we might have to rearrange stuff to begin with, I can show you two very special differential equations that actually have to do with exponential growth and exponential decay. And some of you are like, oh, growth and decay. We saw that in Algebra 2. You saw that in pre-cal. And now you can deal with it so much better in calculus. Okay, as you guys are writing, I did mean to do a spot check. Can you guys just pull out your homework spiral? Just have it open to 5.1. I'm just going to walk around real quick. But what I want you guys to think about is, and you can even collaborate in your groups while I come around and spot check. Don't you have two different differential equations right here? What do you think I want you to do? Solve them. Can you get to where you can tell me what y of t would equal? Just try on the first one, work together in your groups. Can you solve that differential equation? And just a hint, don't move the k. He can stay. Don't move the k. He can stay. Go. Yeah, that works. Good, thanks, bud. Good, thanks. So many different colors in one homework. Okay. Yeah, I see. Thanks. Charlotte, just make sure for the end of the chapter that you show me like grading with color pen. Good. 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 Oh, got it. We got up to like towards the end. Okay. It's okay, maybe. I feel like it's a little mixed. That way they keep looking. That's understandable. Sure for... Oh, you're going to be writing in colored pen. If you can show any corrections, that'd be good. Okay. Oh, we got stuck, huh? Okay, same thing as Charlotte. Just make sure you're showing corrections to get all the points at the end. And then Lucy's saying, oh, no, you showed some. Okay, good. Good, good, good. Just have to figure out number 90. Did today help, though, with number 90? Okay. All right, everyone's good, and you email me, and then David is gone. Okay. Have you guys divided y yet? It's a constant. Just treat it like a number. I know it's a little weird. Just treat it like a number, though. I'm not feeling it. Yeah, Tyler, what's up, kid?
If you have like an absolute value of y, can you just do it?
You can't leave it there because it wouldn't be y by itself, but you can do the plus or minus thing.
What if the y can go on the other side?
Does that make sense? Back to Algebra 1 to take out the absolute value. Ooh, e to the, nice! Good, 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 good. I hear good stuff. I'm going to start playing, if that's okay. Oh, just the first one. Once you get the first one, the last one should make sense. Okay, pause. I made a huge jump for some of you. So make sure it makes sense. I divided the y because he couldn't stay. The integral of dy over y, some of you don't recognize. What's another way of looking at dy over y? 1 over y dy. And who has an integral? Who's the antiderivative of 1 over y? ln. Of absolute value of the y guy. K is a constant. So any constant's integral would be the constant times the variable, but it's not an x this time, so what did I put instead? kt. And then where's my plus c? On this side. I didn't have to show it on both sides. I can just think of, oh, there is one, it moves over, now there's a new one. Now, Sean was like, ooh, you have to do e. Why? We're trying to get who by himself? The y. So I'm going to have to do e to both sides. Now, the absolute value, we'll get to that in a second. But for right now, on the left, doesn't the e and ln, don't they undo each other? They're inverses. Okay. So I end up with absolute value of y. Now, on the right, this addition, now this is super important to see, is this addition able to be ignored and just to be a plus c, or is it stuck right now in the power of e? I had to raise this entire side as the power of e. So the c's stuck, and that's okay. He was stuck in the square root a second ago. Whatever. C just got stuck. Whatever. So now I have e to the kt plus c. Now, hold on. That's just me rewriting what basically I just did. Can we think about exponents for a second? When we add exponents, isn't that the same thing as multiplying like bases? Ooh, check it out. We add exponents when like have been multiplied, right? Now, there's going to be a big jump. E to the c is just a constant. So like the c1 and the c2 could combine to be c, just like the 2 times c could be a new c, e to the c could be a new c. E to the c could be a new c. It's just a constant. E to the 2, e to the 7, e to the -1, e to the, it's just a number. So I can just say, oh, it's this variable expression times a number, which I write in front to be all pretty. Kind of. What Anna is seeing is that e to anything, we kind of talked about it yesterday, e to the x is always positive. 2.718 to 8 to any power. Positive powers will get bigger, negative powers will get closer to 0, but it will never go negative. We do have this little guy right here, which is a struggle, right? However, isn't c whoever we make him? So couldn't we theoretically say, you give me an initial condition and I'll find the right c, whoever you need? So for that reason, we can technically say, since e is always positive and c we can make it work, we can actually take out the absolute value. Oops. My c should not disappear. That's not good at all. And say, you know what, give me an initial condition and I'll make sure it works. You could see it that way also. You could also think growth or decay. If you're talking about the amounts, are you ever going to have negative amounts of something? That starts to be an interesting question. You could have negative rates because it could be decaying, or positive rates, but as far as amounts, didn't come down. We said this can become a c in and of itself. We said this, e to a number, e to a constant, is a new constant. Remember up here how I multiplied the 2 by c and it became a new c? Same base. Yeah. Then I could say e squared is c. So remember, this could be like a c1, and that could be like a c2. And e squared would be there. Absolute value of y. Because it's the rule. Remember the integral of 1 over u or 1 over x is always ln of absolute value of u or x. Oh, the same thing though. Couldn't it be 1 dy over y and then we separate 1 over y times dy over 1? Bye guys. Do you see it? Okay. I can show it. It's okay. Our brains sometimes need a reminder.